Now we move on to the classification of polymers. So there are several ways of classification of polymers based on some special considerations. So now we are going to discuss some of the common classifications of polymers. So the first classification of polymers which we see is done on the basis of monomers. So first classification is on basis of monomers. So on the basis of monomers, classification can be of two types. So the first one over here is homopolymer. Now, as we can see, this homopolymer consists of the word homo, and we know homo means the same. So here there will be only one type of monomer. So in this particular category, only one monomer is used. So if we see an example, we have already seen ethene and styrene. So they both are examples of homopolymer. But we'll see one more example so that we have knowledge of all the polymers and we can quickly place the monomers when we are given a polymer species. Okay. So the next type of homopolymer we'll see is CH2 double bond CH with a CN. Now this is known as acrylonitrile. What is it called? Acrylonitrile. We can see the nitrile group over here, the CN. Okay, so this is called acrylonitrile. When we repeat this acrylonitrile a number of times, so we place an N over it, and on polymerization, that we have already seen the process or the technique of converting a monomer to a polymer is called polymerization. So on polymerization, we achieve our polymer. And the name of the polymer over here is, so first let us draw the polymer. So it will be CH2. We break away the double bond to accommodate the left and the right opening of the chain. Okay. So now since we have taken n amount, so it will be repeated n number of times. And this particular polymer is known as polyacrylonitrile. Okay. Now, polyacrylonitrile can be also called PAN. So, polyacrylonitrile. So, we have seen that only one monomer unit was present, and when we used one monomer to convert it into a polymer, it was known as homopolymer. So, now the second one, the first on the basis of monomer is homopolymer. The second, if we see, it is called copolymer. Now, as the name suggests, co means there are two or more polymers involved. So, two monomers are involved. So, more than one, that means two or more, are known as copolymers. So, copolymer, if we see an example of copolymer, let us take hexamethylene diamine. So, it is represented as NH2. We have CH2 species, that is 6 in number in between, and then again we have NH2. It is added, so this species over here is called hexamethylene, and we can say two amine groups, so it is called diamine. So these is combined with adipic acid. Now adipic acid is represented as such, so we have got a COH group over here, then we have got CH2, 4 in number, and again we have got COOH group. Now this is known as adipic acid. So since we are forming polymers, so we take n units of hexamethylene diamine with n units of adipic acid, and when we combine both of them and polymerization occurs, now we have already seen what a peptide linkage is. So peptide linkage is formed when H is lost. So H will be lost from here and an OH species will be lost from here, and these two will combine to give us a peptide linkage on polymerization, and we can represent it in such a manner. So we'll get N, that is this particular, we are starting from this side. So now we have N, it was connected to an H, and now this is connected to CH2, that were 6 in number. This is coming from hexamethylene diamine. We have got N H. Now one H is lost, and now this is connected to C double bond O. Okay. And now we move on. We have CH2, which is 4 in number. And again, we have got C double bond O. Now, these are this is how the formation of polymer occurs, and we can see that OH over here and an H from this side is lost. Why? Because we have to open the chain on both sides, because we are forming a polymer over here and we have got N units of this. And now the name of this particular polymer is nylon. So this is called nylon 6,6. 6,6 because you can see that we have 6 CH2 over here and we have got 6 number of carbon on this one. So we have got 6 carbons from hexamethylene diamine and we have got 6 carbons from adipic acid, and therefore the polymer formed is called nylon 6,6. So this is copolymer. So we have got two categories on the basis of monomers, that are homopolymers and copolymers. Now moving on to another classification. So the next type of classification that we'll be doing, the second type of classification, is on the basis of source. Now, if we do the classification on the basis of source. So now on the basis of source, these polymers can be classified into three categories. So the first category that we have is natural polymers. As the name suggests, they are indeed natural, that is, they are obtained from plants and animals. So anything, any polymer which we find in nature is known or referred to as natural polymers. Okay, and examples that we can see are cellulose, starch, okay, then we can see rubber. So all of them are natural polymers. Okay. The second category that we see after natural polymers, so we have got natural. If there are natural, there will be man-made polymers, and these man-made polymers are known as synthetic polymers. Synthetic polymers. Okay. So now synthetic polymers are the polymers which are man-made, and a variety of synthetic polymers such as plastic, which you commonly see, also called polythene if we refer to it in chemical terms, synthetic fibers such as nylon 6,6 which we just saw, and synthetic rubbers are examples of man-made polymers extensively used in daily life as well as in the industry. So if we have to give some examples of synthetic polymers, it can be polythene. Then there is nylon 6,6, which we just saw under copolymer category, and synthetic rubber, which is known as Buna S. The third category that we have on the basis of source, so we have got natural, we have got synthetic, and now if we have something in midway between these two, they are known as semi-synthetic. So we have got ourselves semi-synthetic polymers. Now, what are semi-synthetic polymers? They are those which have the properties. So there are some natural polymers that do not have the properties, which are classified as good in nature. Okay. So natural polymers, they are improved by chemical methods. And when man improves these natural polymers, they turn out to be called as semi-synthetic polymers. So semi-synthetic polymers are such examples that we can have are cellulose derivatives. So cellulose is actually, we have seen it under natural polymers over here. And if man made some addition onto the cellulose, so we call it as semi-synthetic polymers. So cellulose derivatives such as cellulose acetate, which is called rayon, and cellulose nitrate, examples like these are called as semi-synthetic polymers. So we can have examples of semi-synthetic polymers as cellulose acetate, so an addition to cellulose which was a natural polymer, and this is known as rayon. Okay, so there are a lot of polymers which are actually natural polymers, and man makes some changes in them, and they came to be known as semi-synthetic polymers. So this classification is on the basis of source.